Welcome to World of DaaS, a show for data enthusiasts. I'm your host, Auren Hoffman, CEO of SafeGraph. For more conversations, videos, and transcripts, visit safegraph.com/podcasts. Okay, hello, fellow data nerds. My guest today is Hilary Mason. Hilary is the co-founder of Hidden Door and data scientist at Accel Partners. She previously co-founded Fast Forward Labs, which was acquired by Cloudera, and served as the chief scientist of Bitly. Hilary, welcome to World of DaaS.
Thank you so much. I'm excited for this conversation.
Excited as well. Okay, so you and I, we met 10 years ago when you were running data science at Bitly. Now, besides for like the tools, I know a lot of the tools have changed. What are some of the big non-obvious changes that's happened in data science since then?
Yeah, it's really fun to think about data science on this order of decades, because we are there for one thing. Like I think in this last year, with all of us staying home, we missed an opportunity to have a really big party just to celebrate that we made it this far. But also because we have a long way to go. So if you think back 10 years ago and what's changed between then and now, you can sort of do it at different layers of the data science stack. So at the bottom, we have infrastructure and even access to resources to make things go. And of course, now we live in this world of like effortless, scalable microservice cloud computing, which even 10 years ago, you had to put a lot of effort into accessing the right compute for the kind of problem you wanted to solve, maintaining it. Like the amount of friction there has just essentially gone close. I wouldn't say zero, but it's dramatically declined. We have made tremendous progress.
Sorry, just to pull on that thread for a second. So there's this percentage of time that a data scientist is actually doing data science, and a percentage of time that they're doing like data munching and data ordering and stuff like that. Obviously, that the percentage of time of the latter is going down. What would you say it was 10 years ago? What would you say it is today?
Of course, the answer is it depends.
Of course, yeah.
But I would say that, and this is tied into my second point, the tooling and the commoditization of capabilities that allow you to easily clean data as long as it, meets, it looks like data that somebody has cleaned before, as well as the ability to model, like both of those things have progressed dramatically. So it used to be that you might be there. Like I still sometimes reach for awk on like a command line because it was in some ways the best way to clean data quickly. Whereas today I would hope that somebody who does not have the scars I have from, 30 years of bash would pick up better and faster tools for those sorts of things. And I think if we go up the stack from tech, of course, we have a bunch of algorithmic capabilities we didn't have 10 years ago. We have lots of SDKs, APIs wrapped around those things. And that sort of both changes the nature of the problems we can approach as data scientists. Like 10 years ago at Bitly, for example, we had a ton of images being shared. We very much wanted to know what was in those images. And you couldn't, that was an unsolved problem. And the companies that existed at the time to solve it had human beings in the background, or did it chose a subset of the problem that was actually tractable. Like we're going to recognize logos in images, but not actually. It was that sort of thing. So that's changed dramatically. And then I think I also want to mention before we move on, there's been a professionalization of data science where it is no longer a novel thing to be a professional data scientist. Like it is actually a job.
It's a real profession today that people have heard of and lots of people do.
That's right. Now, I think if we look 10 years out, we can debate what it will look like to do that job. Like that's kind of a fun direction to go in. But yes, it is an actual job.
Now, the number of data scientists today, it seems like, I don't have the numbers, but it seems like it's at least 10x it was 10 years ago. It's gone up dramatically. Like how do you expect that trend to continue over the next 10 years?
I think we're going to see potentially we might see a fork. We're at a fork in the road. We might see two different things happen, and I don't know which one it's going to be, and it might even be both. The first one is that we just continue on this linear growth trajectory, and 10 years from now we have 100x the data scientists we had 10 years ago, or 1,000. The other way would be that the tools of data science become useful enough that people start to bring them into other professional roles. And so you might lose, or you might have a smaller number of people whose main profession is data science, but we would have data science being done by people whose titles might be things like product manager or
marketing.
Somebody in,
it seems like marketing
absolutely.
can do, a sales manager does data science today, finance person. It seems like everyone is doing a little bit of data science. And maybe they're only doing it today in a crude way, like in Google Sheets or Excel or something. And then we could see that kind of take off a little bit more in the future.
Yeah, and I think personally, I believe that data skills will be a requisite skill in the executive suite and on down for everybody 10 years from now. And they are not today. And this also leads to all kinds of mismanagement of data efforts. But I think it might be A or B or both.
It's interesting because when you think of like a sales manager is extremely data oriented. In fact, many times they're way more data oriented than the engineering manager. The engineering manager, there's a lot of soft things that they need to figure out, whereas the sales manager is very hard on the numbers that they need to kind of these inputs and outputs that they need to do. So you wouldn't think sales is a super data oriented thing, but in fact, it may be one of the more data oriented places in organization.
Well, it is. And it's also when you have something like money that you're quantifying and it's very easy to keep score, it becomes easier to start to become data oriented, where when you have something like software engineering output, like that's I mean, you can quantify it in a few different ways and people certainly try, but yeah, it's hard.
It'd be really interesting if I could have invested in the stock of data science 10 years ago. Like that would have, is there some sort of job today that we will see 10x growth in the future that people aren't thinking about as much?
So I do think that there are professions that that we will see in the future that will see a similar growth trajectory that are adjacent. And these are things like people who can do robust UI design around machine learning. So thinking about systems that may have probabilistic outputs, that may have error, that need to be communicated effectively to, whoever the customer or the user of that system is, that it requires a different set of design tools than the typical sort of UI design toolkit today. And those people already exist, and they're already out there, but I think they're not sort of recognized as a separate.
And do you think it will be, so it'll have a name, like that type of thing will have some sort of name? Because I've seen a few people who are really good at that, but I don't know that there's a way of describing their profession or something.
I mean, product design of machine learning products, maybe something like that. Or maybe it'll just become part of the tools we expect everyone to use. And maybe we'll see the tools that people in that sort of UI design role tend to use accommodate uncertainty and design around machine learning type features as those things become more common. But that's one area where I think that if you are inclined in that design direction, but you're also really interested in machine learning and statistics in the world of probabilities and error bars and all that stuff, like there is a great career for you to have. Like that's one area I would jump into.
One of the things is interesting is it seemed like 10 years ago when I met a data scientist, they were incredibly fluent in probability and statistics. And they had like a deep knowledge of probability and statistics. It seems today that the average data science person has less knowledge of probability and statistics. Is that because there's all these tools that help you abstract some of that? Or first of all, am I right? And then second, is it because there's all these tools and that's less necessary to understand, these deep probability types of things?
I'm not sure I would agree with that. Okay. And, of course, this is the set of people I think about are different than the set you think about, right? So, we could both be right or both be wrong here. I would say that a strong understanding of statistics fundamentals is critical. And it's critical because ultimately the work of data science is trying to make better decisions that are informed by data. And whether you're doing that in a way that a system is automating those decisions, or you're making, a PowerPoint that somebody's going to read and make a decision off of, like fundamentally, you're trying to make a better decision because you have some data. And I don't yes, we have tools that allow you to start to do more interesting work with a lower bar to entry, which is great. But I also think that that skill set is really important because so much of data science is about good judgment and and it's everything from like, how do I frame the problem I'm trying to solve or the question I'm going to ask? How do I know what error metrics, like what does good look like? How do I know when I'm done working on this? And the process of the work is so deeply creative, but also, one of the common failure modes with data scientists, they get so enamored of the problem, they sort of run off and go into a hole and you don't hear from them for a year because they're like way down the rabbit hole doing work that, so much of our work, you get 80% of the value pretty quickly, and then you get to 81% and then 81.5%. And you have to know when to stop, like when is good enough for the purpose of the thing you're building. So I would say that deep understanding of basic probability and statistics, and I don't mean you have to have a PhD in it, but that you do have to be fluent with it, is one of the tools data scientists bring to their judgment.
When you're starting on a problem, let's say you're at a company, like it makes sense to kind of first kind of focus exclusively on your internal data because there's so much low-hanging fruit. And then as you get better and better at like getting those answers, you kind of like further and further on the curve of getting good at data science. Then at some point it makes sense to like bring in external data to help you. Like, is that how you kind of, is there some sort of curve that you see like, okay, let's the lowest hanging fruit and then we'll bring in some external data, or where do you see that continuum?
Yeah, that's a good question. And again, of course, it depends, but
yes,
we do tend to see these common patterns where the first thing is really to understand the product, the business environment, and the data that already exists, understand the provenance of that data, build systems to clean that data, to make sure that when you have 10 people looking at that same data set, they are looking at it in a similar way, if that's the intent, to make sure that they can share work so that if I do the work to write a query and you have a similar question, and this is at the high level of things like, let's say we want to understand like what our weekly active users are, is some new cut of data that pretty much every product has. We should define active the same way, weekly the same way. And these things they sound obvious, they are not obvious, right?
yes.
So like if I give you a number and you do your own work, right, they should match, but they often don't. So it's like just building that first layer of fluency with the data and fluency,
right? Even like, or doing a churn
questions.
analysis or something, like we come up with very, very different answers, just with like a slightly different definitions.
That's right. And so you're trying to have enough empathy for the business problem that you can then go apply it to the data set, and that you want people to be doing that work consistently, unless there's a reason to diverge. So you have to build that base layer of, knowledge of the data and how it was collected, sort of tools and APIs for interfacing with the proprietary data. And then, as you say, I find there's sort of two curves here. One is that sophistication with a company's own data and practices around it.
Yep.
And then there's the sophistication with the set of problems and questions they want to ask, where sometimes you reach a point where you can take a much bigger step forward by introducing new data. And particularly this happens when you have data collected from the world in some way. So like human behavior data. Another one would be things like weather data or environmental data, right? Where bringing in some third-party data that reflects another dimension of the space can actually improve your modeling dramatically, right? And so, yes, I do see this sort of like growth of sophistication and it crosses sort of individual analyst data science practice, team practice, infrastructure, software tooling, all the way up to sophistication of the business in wanting to even ask the right questions or getting more sophisticated in the nuances of the questions they're interested in and exploring those.
The hard part then is like, the data scientist really needs to understand the business, like truly understand the business. Like, how can a company design the organization so that the data scientists can understand the business and not in their own, and they're not just in this like weird pricing optimization thing that they're kind of focused on?
So I love this question because there are several answers and they're all wrong. Okay. And the right answer for a given organization is not the same necessarily as another organization, and it likely changes over time. Like when I started advising companies on data science practice, I thought we're going to come up with the right answer, we're going to implement it, and we're done. And if it didn't work eventually, we had failed. But I've actually come to learn over time that some of the best organizations sort of swing in one direction for a while, realize they've introduced too much friction in another place, and then swing back a bit. So to your first point, empathy and interest and understanding of product and business is definitely required for good data science work, like absolutely required. And also I find—
How would you interview for that? Like, would you just try to like dive into their last business and really try to figure out if they understand it and they have some different nuances of it? Or how would you even know that when you talk to somebody?
So personally, when I interview data scientists, I go at it from two directions. One of which is that I give a hypothetical that is vague enough that they have to ask questions to understand enough to frame a problem. And I give the same hypothetical. And it's one that I always choose a problem that everyone has an intuition for. So it's usually something around like education, food or shopping or something like this. So you would know what questions to ask, but I look for some really clever thoughtfulness around how do I go from this vague, not even clear data science statement to a clear framing of a problem. And then let's talk about techniques.
Yep.
And the other thing I do is exactly as you say, sort of pick something out of the portfolio of projects they say they worked on and say, let's go really deep into this. How did you end up getting to this question? Because of course, the dirty secret of data science is that you start with a question, you realize you can't solve it, you reframe it into a more achievable question, you realize you can't solve that. And so you've like iterated your way 4 questions in before you actually do a piece of useful work. So trying to understand their thought processes and looking particularly in senior folks for the maturity to manage that process themselves. And for junior folks, I look for the interest and curiosity in asking those questions, and sort of, not expecting, because honestly, when somebody comes out of an educational program and they haven't done a lot of this applied work, they often are used to getting these well-formed questions with potential answers for them. Like that's what homework looks like. But the real world is not about doing homework. So it's really looking at their ability to form their own questions out of a bit of a messy problem space.
Okay, really interesting. So, SafeGraph, where I work, we sell data. We sell data to data science teams, but we just sell data, like no tools. Like, what advice would you give to these data companies who are trying to sell data to data science teams? How can they tool it, or how should they describe their data, or what should they be doing to sell well to data science teams?
It is a hard business you are in, for a bunch of reasons. So, and a lot of people think it will be easier than it actually turns out to be, because the first thing is that you have to show that your data is actually valuable. And so do a bunch of work just to do example analyses. Like, here are things that we could be informed by from our data, where we think we have questions that are similar to questions that you, our potential customer, might pose. Then you have to prepare for varying levels of interest and sophistication in the data asset itself. So some people will want it cleaned, pre-processed. They will be happy with your definition of a day. Some people will want everything as raw as possible. They'll think everything you've done is wrong, because it may be, given their stack and setup. And so you have to be prepared to have that conversation at varying levels and potentially even provide both. And then you have the other problem that this is a 2-door sale, because data scientists don't usually have their own budget, or if they do, it's very small. And I assume you don't want to sell your data for peanuts. So then you have to impress the data scientists so much that they go to whoever holds their budget and says, we need this. And you have to impress that person as well. So it's also a challenging sales cycle, which means you have to have both data scientists out there on your sales team, as well as sales professionals who can talk to. And again, because data scientists don't sit in any one part of the org, they have to be able to be fluent with COOs, CIOs, CFOs, CEOs, like head of data science, VP data, digital people. Like, they have to be pretty sophisticated.
Okay, well,
Yeah,
you're
not an easy business
significantly
you're in.
depressing me because we do have this very
Well,
difficult
you seem to
thing.
be doing a great job.
It does seem though that today, I think as you mentioned, like the average data scientist today they just seem way more dangerous, way in a good way. They're way more competent or they can do more stuff because of all these tools that are happening. Like, how do you see that progressing over time? Like, is it just going to be like you said, like the average analyst or the average marketer in 10 years is going to be able to do what the data scientists can do today, and then the data scientist today is going to be just like so much more dangerous, and they can be even more capable 10 years from now? Or how's that going to change over time?
So I hope so, and I hope so, because I think that the more people who don't have to talk to anyone else to use data in their workflows, the better everybody gets at the work they're trying to do. It's going to move much
faster. Yep.
Right. That said, tools always have limits, and they also tend to go wrong. And so, if you were to ask me things like, what about like auto ML that will auto fit, a model to your data and give you a classifier?
Yep.
That works really well when it works. But when it doesn't work, you still need somebody who knows what they're doing to figure out why and what you should do instead. And so I do think we may end up where tooling sort of gives more people more capabilities. And that is frankly only to the good, even if they use them in somewhat bonkers ways sometimes. Like I've had, some of our clients at Fast Forward Labs who are sort of like, okay, do we have to have every analysis everyone produces run through a central data science team to approve it or say it's robust enough? I don't think you need to do that. I think that you can accept that everyone should have the chance to do the work they want to do, and that occasionally some of it won't be great and some of it will be amazing. But then you need to have the specialists who can really go deep on sort of fundamental approaches to addressing new questions where there may not be tooling, or where the tooling falls down given the specifics of what you're trying to do. And what I mean by that is that the more generic a data science like pre-baked solution is, the less accurate it tends to be for your specific use case, because by genericizing it, they have lost information or lost some of the nuance of the problem.
That would be any ML model
Yes.
That's off the shelf today. Okay, got it. Okay.
That's right. And so that's one of the dangers where, yes, tooling will progress, and yes, everyone will be playing with this stuff, but also you're going to need specialists who can, where it's worthwhile, actually sort of invent the approach you should be taking.
And how do you like think about it? Because a lot of times we'll run some sort of model and you get some sort of answer, and then you start to look at it sideways and like that just can't be true. Like and like, how do you, at some point there does need to be a human really like scrutinizing these answers, right? And kind of like, I don't know, taking some other approach to them, like maybe a more qualitative approach.
So I think you're getting at part of what makes a good data scientist good at their job, which is a couple of things. So one is that they have that intuition or that little spidey sense that like, okay, this is too good to be true, or this actually doesn't match my intuition. Let's dig into this a little bit and figure out what's going on. And that quantitative methods are not the end all of data science. In fact, like they often tell you what or how, but they almost never tell you why.
Yeah.
And the why is often,
and if the world changes too, as the world's changing all the time, then
you have no idea.
Yeah.
Right. And so knowing when to actually go talk to somebody who might have some, firsthand experience that can inform the why, or when to sort of throw up a flag and say, we're seeing this, we don't know why, but it's worth highlighting. I can give an example. One company I was talking to a few years ago had this boost in sales for 2 weeks every March. They had no idea why. But it was predictable, like last 5 years of their data, and it was significant. And so, the data science folks working in the CFO's office were like, oh, this is cool. We can predict we're going to get this much more revenue. And the CEO started saying, cool, what's going on? Like, maybe we should understand this. And they're like, oh, we don't know. And it turned out it happened to be one state's, school buying, like their public school system budgets were released exactly at that day. And then they, bought everything in bulk for the whole next year. but they didn't find that out till they talked to the sales folks who are actually on the ground and are like, of course we know what's going on here,
Yep.
right? So it's just putting all these pieces together and realizing that, quantitative methods can help you make the prediction that this happened in the last few years. Probably it'll happen again this year, but it doesn't give you the why. And I think really good data scientists and analysts are good at sort of running up that flag and saying, cool, I have to go talk to someone now to figure this out.
You're really also interested in data ethics, and you co-wrote Ethics and Data Science with DJ Patel, and it's actually free, which is really cool. Anyone can read it. What are some of like the less obvious takeaways that somebody dealing with data should be thinking through?
Yeah, thank you for asking that question. And for everyone listening, you should go get our book because it's very short and very free, and hopefully very fun. But no, we wrote that book because we were looking at a lot of the conversations around ethics and machine learning and AI at the time. This was 3 years ago. And realizing that there were very few resources out there for people who, have hands on keyboard, are doing the work, but want to do it well. There are a lot of philosophical resources. There are lots of critiques, but it's very hard if you're sitting there with a question and you're doing the work to know, like, what are the tools I can apply so that I can be fairly confident that I am doing something ethically and
what's
frankly,
an example of like
an
ethical dilemma that someone might be going through, or there's no obvious answer?
I have seen so many things. Let me think of one that's not obvious. Let's say you're trying to decide something like which marketing segment you want to offer a certain kind of promotion to.
Okay.
You might be very motivated to make sure that you are not discriminating based on, race or gender or other aspects, demographic aspects, but maybe, you want to classify your customers in a different way. That's the kind of questions somebody might be thinking about, is sort of like, what discounts do we want to proactively offer to whom? And what behaviors do we see in our customer base that we may want to understand independently of these sort of crude demographic categories? And that I'm assuming in this hypothetical that we're also in an industry where we're not regulated, because the folks who are in finance or insurance, like, generally have a pretty mature understanding of how to do this.
Yep.
And how to do it right.
Because they've got some FCRA thing or some other type of thing they have to adhere to, okay, or a HIPAA thing in healthcare. Yep.
Yeah, but let's say you're at a telecom company, or you sell like hipster toilet paper or whatever it may be, and you still want to do this fairly and correctly. Like, those are the sorts of questions. I've also seen plenty of issues where people are using data to make fairly significant decisions about consumer access to services, and that data may not directly inform or may have large gaps in it, and it's unclear what you do in the instance of those gaps. Like, do you try and infer missing data? Let's say, you're building a service, but you're missing certain demographics from your data set entirely that may be represented in your customer population. Like, how do you think about that stuff? And with our book, we were not trying to answer these questions at all. We were trying to provide frameworks and tools that data scientists and folks who work with data scientists could apply to answer these questions. And we were also, being honest about it, trying to create a prop for data scientists who had these concerns to bring into their organization to say, here are some people who have been doing this for a while and have some thoughts. We should have a conversation about this, which is why it's a book.
When people present data, and sometimes they're saying like X number of people agree with this, or just like it's sometimes hard to tease out like how true it is. Mm-hmm. Because there's no way to sample everyone in the world or everyone in a certain population or something like that. Even the U.S. Census like misses tons of people and has lots of different flaws. Like, how does one telegraph their biases in a data set to a data scientist in a way where so that data scientists can understand some of those biases and then do their job to account for the biases?
I mean, in this sort of work, which sounds like, you're doing some kind of market surveying, it happens on two sides. So one is good design of the survey instruments. And then
Yeah.
on the other side, robust reporting of error metrics. So often you'll see in the news or a published, sort of marketing type report, like, 98% of customers were not dead after using our product, or some statement like this with a little, so it's really doing the reporting around that so that people can understand, like, how many people what was your sample? Like, what is the denominator of that sample? Like, how did you even come to this conclusion? And, where does it fall, frankly, on the bullshit spectrum? And trying to separate that out from, the work itself, and then how it may be presented or reported as well.
Julie Galef has this really great framework of like the scout mindset versus the soldier mindset. And one of the worries sometimes from data science is it could just weaponize the soldiers, allowing us to prove things that we already believe. Like how do we guard against that? And how do we, as like, is there some sort of like, I don't know, data science profession that we can think through on that front?
So I think it really comes down to, what does excellence in the role look like? And you're absolutely right. I think this is both pretty common and also a dangerous failure mode of the profession, but it also renders the profession useless. Because if, we're just taking what everyone knows already and, proving it, what's the point? Like, why have you invested in paying data scientists, who are pretty expensive, by the way, and all that compute and all that data? Like, you might as well just get to the end result with none of the work. And so I hope that, and I think you see this too in the sophistication and the successful outcomes at different organizations. The ones who do this well, who have a lot of open-mindedness to change action based on what comes out of the analysis, like, they'll do better. And the ones who are just spending money to be told what they already know or already think, they will not do well. Plus, I also, like, great data scientists tend to leave the latter kind of organization. So you also have this sort of polarity of talent, where when you have a team that's really good, it attracts lots of other good people. And when you have a team that's sort of in this, mediocre spot.
Well, but I mean, in some ways, all humans are, we tend to want to prove things we already believe. That is a human trait. And maybe some people do that a little bit more than others, but all of us fall into that trap. Like, is there some sort of hack that a good data scientist could do so they're less likely to fall into that trap?
I mean, I think it's the scientific method, and it's the same in science. And I'm both a CEO and a data scientist. So I think about this kind of thing a lot, where I'm like, if I'm making a decision about what we're doing in our business, is there data that would potentially change my mind or not? And if it's not, I'm not going to bother doing the work. Or is this like a big enough decision to even justify that work, which we haven't talked about at all, by the way. It's like, there are plenty of problems out there where data could inform and potentially improve the outcome, but actually it's not worth it for a bunch of reasons, right? And so it really is keeping, as much as you can, that intellectual rigor around what fundamentally is the scientific method. Like, I have a hypothesis. I agree that this is a way to frame the question and have an answer with robust error metrics that can either inform what I already think or not. And then I'm going to do the work and go from there. And I also, for data scientists, I find that the questions that you can come up with where you don't have a hypothesis are actually the ones that tend to be more meaty and fruitful in the end, because a lot of stuff about most businesses is pretty obvious. And this might be things like, thinking back to social media data, like, people post on social media more when they're awake than when they're asleep. Like, these are the kinds of questions you can end up asking and validating. And maybe that's not so useful to spend the effort on, but maybe asking questions like, are different topics posted on social media at different times of day? And it turns out, yes, like sports, at least a decade ago, this was the case. Like, sports ended up having a very predictable pattern, whereas sort of like generic news happens, all the time, right? Celebrity gossip all the time. So, it's really trying to, trying to dig into those in a way that's honest and useful, but also, if you end up finding yourself asking questions where the answer is not going to change what you do anyway, like don't do the work.
Now back to interviewing, because I know a lot of people are really thinking about how to interview well for a data scientist. And I heard a talk where you mentioned that companies really should do a better job of screening for ethics when hiring data scientists. Like, how do you do that? Like, I could see if you worked with somebody for a while and you kind of then, but how do you do that in an interview process?
Again, try to come at it from a bunch of directions. So ask people things like, tell me about a time when you have disagreed with a colleague and how you resolve that. And then I also like to put a few questions in our technical interviews around things like, let's say you're building a classifier and we'll make it pretty blunt, right? To decide who's going to get a loan and who's not, or how big the loan will be. And it turns out that based on historical data, race is the biggest factor in accurately deciding who's going to pay their loan back and how much money you should lend them. What do you do? And the right answer here is I take race out of the model, I accept the lower accuracy. The wrong answer is, well, I take race out of the model, but I put zip code in because it correlates with race and I just know that. And everybody knows that, right? So like, just looking for whether they even blink at something. That is it about, are you meeting the letter of the law, or are you meeting the sort of spirit and values behind the question? And you would really be surprised probably by how many people like don't even blink and assume accuracy is all they're there to optimize for. When in my view, they are not.
Because for many data scientists, in some ways, like you've been trained to optimize for accuracy ever since, ninth grade math or something. And now you need to take some other like more important societal things into account as well.
Yeah. And I also like to ask questions around, whatever product we're building, like, how do you think this impacts people? What are the things we should be worried about? And so again, it's asking multiple questions to just sort of understand how they think about the role of their work in the world. And I clearly sit in a position where I think data scientists should bring pretty strong values to the work, because if they don't, the potential for harm is great, and that organizations exist as a structure to support and buffer people expressing those values.
I would love to dive in a couple personal questions. So first of all, like you're working on this new thing, Hidden Door. It's really cool. Right. Like, can you just tell us a little bit more about it?
Sure. So at Hidden Door, we are building a social role-playing game for tweens and teens to essentially take the kinds of storytelling play you do in Dungeons and Dragons and in, say, writing fan fiction with your friends, and to do it online. And we're doing it because storytelling is the kind of play we have all done forever, but for the first time, we have natural language processing technology that can actually facilitate and enhance this kind of play. And so we're building tools that allow people to take the stories they have in their minds, but they may not be able to express yet in language, and sort of play with those stories with their friends. So it's something that I'm super excited
we need to double
about.
click on this for a second, because look, when I was a tween, I was a huge Dungeons and Dragons person.
Me
probably
too.
Not surprising to a lot of people. You do? Okay, great. But like to me, that seems like the last thing like computers could help with. How does the computer aid in that, or how does it work on that?
Yeah, so
by the way, why are you just doing this for tweens? Like, I want to play this. Like...
well, that's a separate question. We'll get to that one second. So thinking about the role of somebody who runs a tabletop RPG, so we'll call them the game guide, They do a bunch of things.
The dungeon master.
They progress the story, they set goals, they enforce the laws of physics. So you might say like, my character picks up this teacup and throws it at you. And I'll say, cool, you can do that, but roll to see what the damage is.
Yep.
Whereas if I say, I pick up this building and throw it at you, you're going to say, okay, no, you can't do that. Right. Yep. So this is the kind of capability where we firmly believe that systems are not creative, even deep learning systems that have ingested millions of stories and role-playing sessions, not creative. What they are very good at is providing a palette of options where the players are able to say, I think this sort of thing should happen next. The system fills in details, and then they're like, oh, no, actually it should go over this way. And by the way, we're doing this together with friends. So we're talking about it, we're collaborating. And this is ultimately a co-op experience where we're telling the story together. And so systems are not, they're not writing compelling novels. And if you need, you can go to the internet and see that there are millions of stories out there, and we don't need more stories. What we need are tools that help us tell our stories more fastly, more socially. And that's where we're at with this bit of tech.
That's
As for
so
why
cool.
tweens and teens, frankly, because it's where a lot of the storytelling play happens.
Yeah.
Where folks are starting to experiment with aspects of identity, or using these games as tools for saying, like, what if I was a really brawny sort of person, or what if I was the scholar, who's really into this like obscure kind of magic, right? Or it's not even all a fantasy setting, right? What if I'm in the boarding school and I'm babysitting for a friend and we're having a relationship issue? Like, it's a time in people's lives where the ability to try on an identity and role play it is something that is incredibly powerful. And I am personally very invested in building the tools to allow for that.
Okay, now you have 126,000 followers on Twitter. Last time I checked, you're H Mason on Twitter. Okay, when you started tweeting, like, did you have any idea there was such a big market for data nerds? And and then if someone else is a data nerd and they want to increase their public profile, like how do one go about doing that?
So to answer the question, when I started tweeting, Twitter was not that big. So
yes,
no,
okay.
I had no idea. And like, yeah, if you'd asked me,
there may have been less than 126,000 people on Twitter.
There definitely was. And it was also the kind of thing where I think if you go back and look at my stuff from like 2007, it's like, I made a bunch of cookies. It's a lot of, why are zip codes so weird? It's a lot of that kind of stuff. As for, people who want to have a public profile, first I would say, think about whether you really want to, because it's not always a positive. I mean, you basically get people retelling your own jokes back to you, but dumber, like every time you share anything. But the other side of it is, like, I meet so many interesting people and have so many random connections because of it that I just can't give it up. It's too much fun. And then for people who want to have a public profile, it involves, I think, just having opinions about things. And this is not to say like hot takes on the news of the day, but really having a point of view on a practice that other people are also interested in, and then sharing that point of view where it's interesting and helpful. And of all the stuff I share, which by the way is not all about data, I'm a huge like pro New York nerd, so fair bit of New York stuff in there, fair bit of just weird history of tech, especially, and art. And then a fair bit about data. The things people seem to respond to are the things where you're sort of saying an opinion, like a point of view on something clearly, so that people can build off it in developing their own points of view. And it's best if it's based on experience or excitement. And the other thing about having a lot of Twitter followers that I really try to do is to highlight interesting work being done by other people who don't have 120,000 Twitter followers, so they can get some of that attention. Awesome. Particularly like lots of diverse folks doing really interesting data science stuff, sort of, in whatever they're super nerdy about, sort of love to pull that out and highlight it.
Oh, cool. The last question that we ask all of our guests, if you can go back in time, what advice do you wish someone had given to your younger self? Let's say Hilary Mason at 18.
Gosh, at 18, I would say something like, when a cute person asks you out for coffee, you don't have to drink the coffee and you should go. Because I was sort of an idiot. But
wait. So well, let's go back to what do you mean by that? If someone asks you out for coffee
at 18, and I probably missed out on a lot of social opportunities because people were like, "Let's get a coffee." I'm like, "Oh, I don't drink coffee."
Oh, got it. Okay, you didn't get the next level. Okay, yeah.
Right. Yeah. So the advice I would give myself back in time is that I've been extraordinarily lucky, and a lot of that luck has been a function of pursuing the things I was already interested and excited about, and then meeting the people who are also excited about those things without being ashamed of them. And so I remember a time along the same lines as the coffee thing, when like telling someone at a party I was working on machine learning, was enough for them to be like, okay, I'm going over there. Like nobody thought it was cool. It was not cool. But I was interested in it, and it was enough to like keep that passion and excitement. And I still have that. And so I would say, like, find the things you're interested in, find your people, because they are out there. And that may involve going to somewhere like New York or San Francisco, or online somewhere where those people gather, right? Find your people and just pursue those interests because they're interesting to you. And that will give you, whether it becomes your job or not, like it will give you enough of an interesting and valuable perspective on something that you'll be able to apply it to other areas in a way that'll be really useful and interesting. And in my own career, I've been a data scientist, I've run data science teams, I've been a CEO, I've built products, but having that deep interest in, sort of machine learning and data science and computer science and things like operating systems has, even though it's very specific and pretty nerdy, has become very useful in these other domains as well. So I just say, find that thing you're super into, find your people, and then have fun with it. Like never lose the fun.
This is great advice. Thank you very much. Now, besides for people following you on H Mason at Twitter, where else can people learn more about you?
Yeah, so our company Hidden Door is at hiddendoor.co, and you can find out more about me at hilarymason.com.
Awesome. Thank you so much for being with us on World of DaaS.
Thank you. This has been a lot of fun.
Thanks for joining us. If you enjoyed the show, consider leaving a review. For more World of DaaS, and that's DAAS, DaaS, you could subscribe right here on our YouTube channel, or you could find me on Twitter at Auren, AUREN, Auren. I'd love to hear from you.